Hello everyone, my name is Yatin Gupta and I welcome you all to my channel Double E Concepts. So we were covering the basics of network theory, and in that series my next topic is mesh analysis. So today in this lecture I will cover what is the difference between a mesh and a loop. Then we will see what are the steps involved when we do the mesh analysis of any circuit. And then we will also solve one example using the same technique. So let's start today's lecture with our first topic, which is difference between mesh and loop. So basically, what is a mesh and a loop in any circuit? If you pay your attention to this circuit here, I have drawn some loop, some closed paths like this. So basically, what we say that a mesh is a loop that does not have any inner loop. So if you're calling a closed path a mesh, that means you cannot create any inner loop from that. So if you consider this M1, M2, and M3 closed path here, you can clearly see that in this closed path, you cannot create any inner loop inside it. So this will be called a mesh for you. And if we talk about these two closed paths, one that is drawn here in red color and the other one, this one. So you can clearly see that this closed path is having two inner closed paths as well. The first one is the M1, M2, and the second one is the M3. So this closed path will be called a loop because you can create multiple meshes from this closed path. So this will be called a loop. So M1, M2, M3 are the meshes here, and L1, L2 are the loop. So this is the basic difference between a mesh and a loop. Okay. Now coming to the steps involved. So basically mesh analysis is a method of calculating the current flowing inside each mesh of a given circuit. Okay. So we will consider this particular circuit here and then we will discuss about the steps. So the first step here is find the number of meshes in a network and label a current flowing in each mesh. So take a circuit, then try to find out how many meshes are there in it. Okay. Do not take any loop. Try to find out the meshes which does not have any inner loop. So if we talk about this circuit, then I can see one mesh here, which is I have labeled as I1, current I1. This is M1 mesh. The second one here is this M2 mesh, which is having a current of I2. And the third one is M3 mesh, and I have labeled the current as I3 here. So this is the first step, identifying the meshes and labeling one current to each mesh. Coming to the next step, if a branch is common in two meshes, then the current flowing in that branch will be the difference or the sum of current flowing in that branch. So let's understand this line. If you see this AB branch here, this is the common branch between this M1 mesh and this M2 mesh. So the current that will be flowing in this branch will be either the sum or the difference of this I1 and I2. Now it will depend on which direction you have taken for the currents. Like here I have taken both the directions in clockwise. Okay. So definitely this I1 will be flowing from top to bottom, A to B, and I2 will flow from B to A. So in that case, I will be writing the difference of these two currents. Okay. And if I had taken one clockwise and one anti-clockwise, then it would have been the sum of both the currents. Okay. So that depends on what direction you take. So the next thing here is the priority will be given to the current whose mesh equations we are writing. I will explain this line to you in the next slide when we'll be solving one question related to this topic. Then this will be more clear to you. Okay. Now in the next step, you start writing the mesh equations, or I can say KVL equations for each mesh. So you have decided how many meshes are there, and then you will start writing the KVL equations. So first you will write for this loop, then for this loop, and then for this last loop. Okay. And after solving all these mesh equations, you will get the value of each mesh current. Okay. Now let us solve an example related to this particular method. So we'll be trying to calculate each mesh current in this below given circuit. Okay. So in the first step, we will first try to find out how many meshes are there. So we can clearly see that there are three meshes here, M1, M2, and M3. So I have labeled three currents, I1, I2, and I3 here in the clockwise direction, same direction. Okay. Now, as I have told you that priority will be given to the current whose mesh equation we are writing. So this will be clear to you now. I'm writing the mesh equation or the KVL equation for the first mesh, M1. So I will start from this reference point. I have taken this as my reference point. And now I'm going in this direction. The first voltage rise that I'm seeing here is 10 volts. So minus to plus I'm going. I take it as a positive. And when I'm going from plus to minus, I take it as negative. You can take the reverse also, but use that only in throughout your calculation. Okay, so this will be 10 minus 2i1 minus I1 minus I2. So why I have written it like this? I'm writing the mesh equation for which mesh? M1, right? So I1 is the current in M1. I will give the priority to I1 here. So giving the priority means I will consider that I1 is greater than I2 here. So for this common branch, I will write I1 minus I2, considering that I1 is greater than I2 in this case. Okay. Now this condition will change when I'll be writing equation for the second mesh. So for the second mesh, my equation will be like this. Starting from the reference, I'm going in this direction. So this will be I2 minus I1. So right now I'm writing I2 minus I1 because I'm writing equation for the second mesh. So I'm giving priority to I2 here, considering that I2 is greater than I1. So this is the meaning of this line that I have written here. So it will be I2 minus I1 into 1, then this resistance drop, I2 into 1, and then minus again. Writing equation for which current? I2, right? So I2 minus I3, not I3 minus I2, and multiply by 4. So this is the second mesh equation. Coming to the third one, which will be 4 into I3 minus I2, and then minus of 6 I3. This will be minus sign here, so you can correct that. Okay, so we have three mesh equations with us with three unknown variables I1, I2, and I3. So this can be easily solved, and you will get the values of I1, I2, and I3, all the three mesh currents. Okay. Now coming to the next topic, which is how many number of equations do we need to solve a circuit using the mesh analysis? So let's just say a circuit is given to you, and someone asks you that how many equations you're going to need if you want to solve this circuit using the mesh analysis, if you want the values of current using the mesh analysis. So for that, we use this formula here, m equals to b minus of n minus 1. Here, b is nothing but number of branches in the circuit, and n is number of nodes. Now, while using this equation, you need to keep two things in your mind, two important things. The first one is, do not consider a mesh in which the current is already known. So there might be a condition while solving a circuit that you will already be knowing the value of current that is flowing inside that particular mesh. There will come a situation. So in that situation, whatever value you are getting with this particular formula, you will subtract that from that. So if you know one mesh current value, so you will subtract one from this. Let's just say you need four equations. You need four equations to solve a circuit, but one mesh current is already known to you, so that will be three mesh equations, not four. Second thing is, while counting the total number of nodes, you also consider the reference node. Okay, so there will be multiple nodes in the circuit. While counting all the nodes, you also count the reference node always. Now, let's take example of this circuit here. In this circuit, if I try to calculate how many equations I need, then I will try first calculate how many branches do I have. So this is one branch here. If I do not consider the simple node, only the principal node. So one branch is here, second, third, fourth, and fifth. Total five branches. And number of nodes are how many? This is one node, the second node, and these two are both of these nodes are the reference nodes. So I'm considering it as one. So one, two, and three. So B is 5, N is 3. We can calculate the value of M, which is going to come out as 3. Now let us consider that case also when you already know the value of one mesh current. Okay, so take this circuit for example. There is a current source connected in this particular mesh. So you already know the value of current in this mesh, which is 2 ampere. So the current that is flowing here, I3, will be nothing but 2 ampere. So while calculating the number of equations with the formula, you just subtract 1 from that and you will get the answer. So I3 is already known, so this will not be counted. Okay, guys, so that's all for this lecture. I hope you have understood the concept of mesh analysis. In the next lecture, I will solve some more problems related to this topic only, mesh analysis, and then we will jump to our next topic, which is nodal analysis. Okay, so thank you very much for watching this lecture. I will see you in the next one. Thank you so much.